Good morning, good afternoon, good evening, class. As Mr. Arosena. And today I'm going to go over the Naming Alkanes worksheet number 1. Okay. So last time we talked about alkanes, sort of gave you a rundown on how to name alkanes. So that's what we're going to basically do. Here we have a bunch of alkanes. They are done in condensed form, so not line form. I usually draw things in line form and not in structural form, but they're done in condensed form. So I'm going to do two things with this. I'm going to show you how each of the following compounds looks in line structure form and how to name them. Alright, so first let's redraw this one in line form. So in line form it would basically look like this. You would have your 3-carbon chain would look like this. 1, 2, 3. That carbon would stick out. I guess I'll stick it out there. There you go. So carbon, 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 carbon. Okay, now you don't have to actually draw those carbons in, so I'm just going to take those out and I'm going to leave the line structure looks like this. Okay, so when we're naming a branched alkane, we have to look for first what is the longest carbon chain possible. Here it is going to be 1, 2, 3. So it says 3-carbon chain is the longest. So this is going to right away I'm going to put down the name of a 3-carbon chain, which is propane. Okay. Next, we determine what is branching. In this case, we have a single carbon branch. Single carbon branches we call single carbons are meth, but a carbon branch is called stands in L, so methyl. And the last thing we need to do is what carbon is that methyl group attached to? It is the number 2 carbon. So the first one there is going to be 2-methyl propane. Alright, the next one, number 2. Let's see a different color. So here, let's draw this out. So I'm going to go 1, 2, 3, 4. So this would go 1, 2, 3, 4. We have a single carbon chain on the number 2 carbon, so I'll do that. So that's what it would look like as a line. And to name it, well, I've already numbered the longest carbon chain, 1, 2, 3, 4. So this is going to be a butane of some sort. Butane. I've circled the branch, which is a single carbon, which is, again, a single carbon branch is called a methyl. And that one appears on carbon number 2, so this is 2-methyl butane. Alright. This next one is kind of long, so let me start numbering the carbons. 1, 2, 3, 4. I could go 5, 6, but I think if I go 5, 6, 7, that results in a longer chain. So this will be 4, 5, 6, 7. And then this ends up being what my carbon branch is. Okay, so the longest carbon chain is a 7. So we'll start off by calling this a heptane. Okay. I have a single branch. It is a 2-carbon branch. So 2 carbons are eth. But because it's a branch, it's called an ethyl. And then that carbon branch appears on the number 4 carbon, so this is 4-ethyl heptane. Okay. Now the next one. This one might require some trial and error. Alright, let's count. I'm going to say I think the longest chain will be this. 1, 2, 3, 4, 5, 6, 7. Although I could have easily also gone 5, 6, 7 that way, and it will still get me 7 carbons. Okay, so I'll leave it like this. We now have a methyl branch here. We have an ethyl branch here. But I'm getting a little ahead of myself. So let's start off with a heptane, because that's the longest carbon chain is a heptane. Okay. I'll list the 4-methyl first. So we have 4-methyl, and then at the 5 carbon we have an ethyl group. 4-methyl, 5-ethyl heptane. That is what that compound is. Okay, the next one, again, number the carbons. 1, 2, 3, 4, 5. If I continue going, that'll give me 6, 7. But I think if I count the other way, I get a longer carbon chain. 6, 7, 8. So this is going to be an 8 carbon chain. So this will be an octane. We have a carbon there, or carbon chain there, and a carbon chain there. So this will be 3, carbon 3. We have a 1 carbon chain, which is methyl, followed by, on the 5, we have an ethyl group on the 5. So this is 3 methyl, 5 ethyl octane. Alright, the next one is kind of big. There's a lot of carbons. Alright, let's count them up. 1, 2, 3, 4, 5, 6. Now, here we can branch off in 3 ways. We could either go to the left and add 7, 8, 9, 10, which I think is actually the biggest there. The other ones, yeah, we're going to bring it up. So 10. 10 carbon chain is a decane. Now we just have to look for, what are my branches? My branches are a methyl and an ethyl. Now, you may want to write this right away as a 6 methyl, 6 ethyl decane, and it would not technically be wrong, but chemists do have a convention. The one convention we have when writing organic compounds is we try to get the numbers to be as small as possible. Okay, so we wanted to get these numbers as small as possible. If I renumbered it, so let me renumber it. If I renumbered it this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's still a decane chain. We can still put a decane, but this time my groups are no longer on the 6 carbon, they are on the 5 carbon, simply because I renumbered my carbons. And we can do this. There's nothing wrong with renumbering the carbons. Okay. So there it goes. This is a 5 methyl, 5 ethyl decane. Now, the previous one, the 6 methyl, 6 ethyl decane, was technically not wrong because it still accurately describes what the compound is. But by convention, we kind of want to have the sum of these numbers to be as small as possible. Okay. So watch out for that. Watch out for that. Make sure that when you number your carbons and you get those, is there a smaller set of numbers I could use to describe the same compound? Okay. It's a neat, interesting convention we have. Alright, the next one. I'm not sure where to start here, so I guess I'll start here. At the top? Yeah, I'll start at the top. So 1, 2, 3, 4. And from here, it's obviously we branch to the right, so 5, 6, and we'll branch down 7, 8, 9. So there's 9 carbons in this chain. This is going to be called a nonane. 9 carbon chain is called a nonane. Now let's take a look and see. If I renumbered it, would I have smaller numbers? Well, before I do that, I'll look for my carbon chains. I have a methyl and an ethyl group. The methyl group is on the 6, so 6 methyl. And then we have an ethyl group on the 4. So that's a 4. 6 methyl, 4 ethyl nonane. Okay, now if I were to renumber it the other way, and I'll write it in a different color to show you the difference. No, just smaller size. If I numbered it this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, would I get a slightly smaller number? Well, let's write out this way. So it's a nonane. but this time I have a 4-methyl and a 6-ethyl. So it doesn't actually change. If I renumber it, I still get the same set of numbers, but this time the methyl's on the 4 and the ethyl's on the 6. Okay. In this case, renumbering it didn't really change anything. It still gave me effectively the same name, same numbers. Okay. But sometimes, like in the number 6, the renumbering it did actually make the numbers smaller, because it went from 6-methyl, 6-ethyl decane to 5-methyl, 5-ethyl decane. Okay. That's just something to keep track of. Again, I don't think there's anything technically wrong with using the larger numbers, but we just like to use smaller numbers. Alright. So, the next set of questions is going the other way, where you're given a name and we're going to write draw the compound structure for it. So the easy way to do this, the first thing you want to do is look at what is the backbone, what is the carbon backbone. In this case, it's an octane, so I'm going to draw an octane first. So I'm going to use a line diagram. So 1, 2, 3, 4, 5, 6, 7, 8. Remembering that each of these points is a carbon. I'll write it in explicitly. And then we just number them. We want an ethyl group on the number 4. So 1, 2, 3, 4. So here we're going to have an ethyl group. The ethyl group is 2 carbons, so I'll go like that. There we go. That's what 4-ethyl octane would look like. If I had to draw it a lot cleaner, I would do the following. Oops. It would look like this. 1, 2, 3, 4, 5, 6, 7, 8. There we go. And then I would go 1, 2, 3, 4. So on the 4, I would draw an ethyl group, which would look like that. And then continue numbering 5, 6, 7, 8. There you go. So that's another way to draw it. Okay. Alright. Next one, nonane. So nonane is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have a methyl group on the number 2 carbons. If I number the carbons 1, 2, we have a methyl group there. Which is just a single carbon, or I guess a single line for a single carbon. Okay. Alright. The next one looks complicated, but it's really not. Just look at this. We have a butane. So butane is 4. 1, 2, 3, 4. At the 2 carbons, if I number them 1, 2, I have a methyl group, which is 1. And I also have an ethyl group. So I drew my methyl and I have an ethyl group. So an ethyl group would look like that. There we go. All branching off from the number 2 carbon. As follows. Okay. So, but as you can see for these last 3 examples, all you really do is identify what is your final, or what is your backbone, in this case a butane, draw the backbone, and then add the branches based on where they're located. So let's look at number 11. We have a 3-ethyl pentane. So backbone, pentane, draw 5. So 1, 2, 3, 4, 5. And at the 3 carbon, so 1, 2, 3, we have an ethyl group. An ethyl group, again, just like this. There we go. Right, so hopefully this is making sense. One last one to do. 2-methyl, 3-ethyl heptane. So a heptane is 7 carbons. So 1, 2, 3, 4, 5, 6, 7. And then we have a methyl group on the 2. So that would look like that. And we have an ethyl group on the 3. And that will look like this. 1, 2. There you go. That is how we can draw structures for organic compounds, or at least for alkanes. Okay. Hopefully you guys did okay on that. Should have enough. Hopefully this will help on your assignments, and you guys will have another one. Yeah, you'll have another similar worksheet to this. Okay. All right, good luck. If you guys have any questions, you know how to contact me.